Hello, my name is Shretanna, SAP number 54, batch B3 Electronics. And today in this experiment, I'm going to explain about linear equation solver, adder, and subtractor design using operational amplifier using Ltspice software. So we'll be creating a new file. We'll be using OP07 as an operational amplifier. We'll be using different resistors, and in this case, we'll be using resistors of 10 kilo ohms each. We'll be grounding this terminal. We'll be measuring output here, so we'll label this as V out. We'll be using an feedback resistor of 10 kilo ohms. We'll be grounding this terminal. We'll provide voltage to this terminal. We'll ground the negative side. Now we'll be giving resistors the value. Each resistor is of 10 kilo ohms. We'll be supplying voltage value of 3 volts to VB and 2 volts to VA. We'll rename this as VB and VA. 15 volts to the op amp. Okay, so everything looks fine, and we'll simulate this. So as here we can see, we'll be getting the value as minus 1 millivolts, minus 999 millivolts, which is equal to 1 volt. Since this subtractor will calculate VA minus VB, we'll get output minus 1 volt. Similarly, we have created other subtractor and linear equation circuits. This is linear equation circuit number 1, which has the value as 2VA plus 3VB minus 4VC. We'll be supplying VA, VB, VC each as 1 volt. So we'll get the output by simulating run. So as we can see, we'll be getting 1.030 volts. Now opening the linear equation second. The circuitry remains the same, only the changes we have made is the voltage supplied to VA, VB and VC. VA will be getting 2 volts, VB 1 volt and VC 2 volts. We'll go ahead and simulate it. As here we can see, we'll be getting negative value minus 9.969.74 millivolts. This is the third linear equation circuit. The circuit remains the same, only changes we have made is the voltage supplied. 5 volts, 1 volt and 2 volts. We'll simulate it and get the output. As here we can see we'll be getting output as 5.030 volts. This was all about linear equations. Now I'll be showing you adder circuits. This is a non-inverting adder. Here we have used the value of conventional values, which is 3.9k, 1k and 100 ohms. Here we have used 10k, 10k, 10k each, and the voltage is supplied. It is called as non-inverting adder since the voltage supplied is to the non-inverting side. So VC will be 2 volts, VB will be 3 volts, and VA will be 4 volts. We'll get the value when it's simulated. As here we can see we'll be getting 8.999 volts. Similarly, we have made another non-inverting adder. The only difference is that we have changed the input supply voltages: 5 volts, 1 volts and minus 6 volts. No changes on the inverting side. We'll go ahead and simulate it. As here we can see we'll be getting minus 0.008581 volts. Now add a circuit 3. Only changes we have made is the voltage supplied: 1 volt, 3 volts and 1 volts. On simulating it, we'll be getting as 4.999 volts, which is 1 volts plus 3 volts plus 1 volts, which is almost equivalent to 4.995 volts. This was all about the adder circuits. Now I'll be showing you the subtractor circuits. This circuit we have already seen. The output Vout will be Va minus Vb. So in this case it will be negative 1 volt. Let's simulate it. Here as we can see we are getting almost equivalent to 1 volt minus 1 volt. Now the second subtractor circuit, the only changes we are making is we are changing the input voltages. In this case it will be positive 4 volts since the equation is Va minus Vb. Let's simulate it. Here we are getting as minus 3.99 volts, which is almost equivalent to 4 volts. So this was all about experiment number 2 of linear equation solver adder and subtractor design. Thank you.